Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how to convert between mass and number of particles. So let's get into this. So our first problem is how many copper atoms are in a copper penny that has a mass of 3.10 grams. Okay, so when you're trying to convert between mass and number of particles, one of the conversion factors that we're going to need is Avogadro's number, or 1 mole is equal to 6.022 times 10 to the 23rd. So I'm going to write that up here. So 1 mole is equal to 6.022 times 10 to the 23rd. Okay, so that's going to be a very important conversion factor because remember, the Avogadro's number, this relationship between 1 mole and the number of particles, and again, this is going to be number of particles, 6.022 times 10 to the 23rd particles. And the particles could be any particle. It could be eggs, it could be people, it could be cars, it could be atoms, it could be moles, it doesn't matter. So 1 mole of anything is going to be 6.022 times 10 to the 23rd of that, or parts or particles of that thing. Okay, so that is the first conversion factor. The other conversion factor that we need to go from mass to particles is the molar mass. So remember, molar mass is the number of grams per mole of a substance. So 1 mole of the substance is going to equal to a certain number of grams. So we're going to need molar mass. And that is a certain number of grams per mole. So that's going to be useful for converting between grams and moles. Okay, so now let's apply that to our problem here. So we need to figure out how to get from grams, because they're giving us grams and they're asking for number of copper atoms. That's a particle. So we need to go from the mass in grams to the particles, which is atoms. So the first thing we want to do is start with the given 3.10 grams. And this is grams of copper, since we're talking about penny and they want copper atoms. And here we're assuming that the penny is completely copper. Of course, pennies are not completely copper. They've got copper coating with some zinc. And so it's not purely copper. But we're assuming here that the 3.10 grams is completely copper. So we're going to say copper We're going to put that over 1, and then we're going to start converting until we get to atoms of copper. So I need the molar mass. So what's the molar mass of copper? You look up on your periodic table, Cu for copper, and we see it's 63.55. So 63.55 grams, that's an ugly 5, of copper. I'll use Cu, the symbol for copper. So I have grams of copper here. I want grams of copper here to cancel out. And so 1 mole of copper goes on the top. So grams of copper cancels out grams of copper. Now I have moles of copper on top. I'm not there yet. I'm not done because I want atoms of copper. Do I have atoms of copper? No. So I need to keep going with the conversion factors. So I have moles on top. Now I can use Avogadro's number. 1 mole is equal to 6.022 times 10 to the 23rd to convert to atoms. So that means that 1 mole of copper is equal to 6.022 times 10 to the 23rd, and I'm going to extend this, copper atoms. So moles of copper now cancel out. Now I have copper atoms on top. That is what the problem is looking for. So I'm done. I don't need any more conversion factors. So now all I need to do is multiply across the top, divide by what's on the bottom, and I get my answer. So when I do that, I get 2.9375. I'll write it down here. So this is equal to 2.9375 times 10 to the, what power is this? 22. Okay, so now I have my number. Now I have to worry about significant figures. So for those of you who need to be able to express your answer in significant figures, this is going to be important. So remember the rule for significant figure, the rules for multiplying, dividing. When you multiply and divide to get your answer, then the number of sig figs is determined by the least number of sig figs in the numbers that you are multiplying and dividing. So in other words, your answer should have the same number of sig figs as the measurement that with the least number of sig figs. So we got to go back here. So we got 4 here, 4. We got 4 here, and we got 3 there. 3 is the smallest, so that means we can only keep 3. So that means we keep the 2, the 9, the 3. We cut it off there. So then everything else, the 7 and the 5 are dropped. So then this would then become 2.94 because the 7 here is greater than 5, 5 or greater. So this number here, when it's 5 or greater, you got to round up the number next to it. So that's going to be 2.94 times 10 to the 22nd, and that's going to be atoms of copper. That's hard to read. So copper, atoms of copper. Okay, what about this one now? Here we're going to be going in the opposite direction. So we're asked to calculate the mass of 2.25 times 10 to the 22nd tungsten atoms. So here we're given a certain number of atoms and we're asked to convert that to mass. And if they don't tell you what unit, then just assume grams. Make your life easier. Okay, so we're going to convert this to grams. So we got to start with the particles, start with the atoms. So we're going to write 2.25 times 10 to the 22nd power. And this is, we're going to do tungsten. So W is tungsten, capital W, atoms over 1. Now we're going to multiply by our conversion factor. Since we've got particles here, we need to convert particles to something else. We have a relationship between particles and moles, so let's convert to moles. So we're going to put the particle on the bottom, so atoms goes on the bottom. So we're going to have 6.022 times 10 to the 23rd. And that's going to be tungsten atoms. And then we're going to have 1 mole of tungsten on top. So tungsten atoms cancels out. Now we have moles of tungsten. So we don't want moles of tungsten. We want calculate the mass. We want mass in grams. So we need to convert to grams. So we're going to use the molar mass of tungsten. So let's look up the molar mass of tungsten. So tungsten has 183.84. So let's go ahead and do that. So let me look again. Again, that's 183.84. So that as moles. So 1 mole is equal to 183.84 grams. So I want moles on the bottom. So I'm going to put 1 mole of tungsten and 183.84 grams of tungsten. So moles of tungsten is going to cancel out. I have grams on top. Grams or mass is what they're asking for. So I'm done. So now all I need to do is multiply by everything on the top, divide by everything on the bottom, and I get my answer. So when you calculate that out, we get 6.86. So I'll put it down here. We get 6.86, and I think it's 88. Yes, 688 grams of tungsten. So again, for those of you who need to be able to record this in the proper number of sig figs, again, the rule for multiplying and dividing is that your answer that you get from the multiplication and division should have the same number of sig figs or significant figures as the measurement with the least number of sig figs that you multiply and divide it. So if we look at our numbers here, here we have 3 sig figs, 2, 2, and 5. That's 3 sig figs. Here we have 4. Here we have 5. So 3 is the smallest number of sig figs. So we can only keep 3. So we're going to have to chop it off after this. 1, 2, 3. So we'll drop these numbers. But remember, this number here, the one that follows our last number that we can keep, that is 5 or greater. So it's an 8. So that means we need to round the 6 to a 7. So our final answer is going to be 6.87 grams of tungsten. And that, ladies and gentlemen, is how it's done. I hope you enjoyed this video. If you did, then please like the video, share the video with your friends. Make sure you hit that like button over there. And also subscribe to my channel, hit that notification bell. And when you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment box. If you think, ask me questions. I would love to hear from you. If you have any ideas or suggestions for future videos, let me know. I would love to do that for you. Thanks for joining me and have a great day.